Section 8.5 is about applications of matrices and determinants. So in Chapter 7, we studied the methods of substitution and elimination to solve systems of equations. These processes could be compounded into producing systems in row echelon and reduced row echelon form to yield solutions. We did that back in Section 8.1. An additional method we will study in this section utilizes matrices and their determinants, and it's called Cramer's rule, named after mathematician Gabriel Cramer. So the solution to the system uses determinants to write the solutions to a system as fractions with numerators and denominators that are determined by various determinants within a matrix. Holy cow, that's a lot of words. Let's talk about what that means. So here's an example of a system. And let's say our system, we've got a sub 1 times x plus b sub 1 times y equals some constant c sub 1. And our second, oops, there should be a sub 1 there, a sub 2 times x plus b sub 2 times y equals c sub 2. So the a's, b's, and c's are just constants, coefficients for a and b, and then constants for c. The x we can determine by doing the solution to this, the x solution, we can do c1 times b2 minus c2 times b1. That kind of sounds like a determinant that we were using earlier. We'll get to that. And then the denominator would be a sub 1 times b sub 2 minus a sub 2 times b sub 1. Also kind of seems like a determinant. So with the determinants, with those being like determinants, let's talk about the matrices that they might be related to. So the matrix relating to the top would look like this: c1, b1, c2, b2. The matrix related to the bottom part would be a1, b1, a2, b2. And we're going to give those two specific ones, those specific determinants, names. We're going to call the top one d sub x, and the bottom one we're just going to call d. Now, we got something similar to solve for y. The numerator looks a little different, similar in nature. The denominator is the exact same. So we've got a sub 1 times c sub 2 minus a sub 2 times c sub 1. And then our denominator is the same as we got for the x. It was a sub 1 times b sub 2 minus a sub 2 times b sub 1. So our numerator looks like a determinant, and that determinant would come from the matrix that looks like this: a1, c1, a2, c2. And the denominator, it's the same determinant, the same matrix that we were using on the x solution: a sub 1, b sub 1, a sub 2, b sub 2. And the numerator, that's going to be called d sub y, the determinant for y over d. So again, the numerator d sub x the numerator for x is d sub x, and the denominator is d. And the numerator for y is d sub y, and the denominator is also d. So let's first figure out how the heck to even write these. So given the system, 2x minus 5y equals 3, and negative 4x plus 3y equals 8, we're asked to do three things. We got coefficient matrix d, d sub x, and d sub y. The coefficient matrix, we'll start with that. The coefficient matrix is just making a matrix out of our coefficients. So our top row is going to be 2, negative 5. Our second row is going to be negative 4 and 3. D is just going to be the determinant version of that. So it would be 2, negative 5, negative 4, and 3. And then d sub x would be, and this is where things are going to get a little tricky. Let me actually emphasize something here. If we're to make this into an augmented matrix where it's 2, negative 5, 3, and negative 4, 3, 8, and then over here we got, this is our dashed line here. Kind of labeling these are the first column would be our A's, second column would be our B's, and the third column would be our C's. Now I want to highlight the C's because that's going to be the thing that kind of affects what's going on. So d sub x, the way d sub x would look would be 3, negative 5, 8, 3. Now where these numbers come from, we're essentially replacing the x row with our constants. Again, in d sub x, you're replacing your x row with your constants. Similarly, d sub y, we would replace our y column with our constants. So we're going to leave the x column alone, so 2, negative 4, and our y column we're going to replace with the x, wow, sorry, I wrote the wrong column. We're going to replace with the constants, so it's going to be 3, 8. So again, the y column from our coefficient matrix gets replaced by the constants in d sub y. Now we can also do the actual determinants for each of these. So like d, the determinant of that matrix, we would do 2 times 3 minus negative 4 times negative 5. So we got 6 minus, negative 4 times negative 5 is 20. So we got 6 minus 20 gives us negative 14. For d sub x, we would do the diagonals. We do 3 times 3 minus 8 times negative 5. That gives us 9 minus, well, it's going to be negative 40. So I'm just going to say plus 40, so which gives us 49. Finally, d sub y, we would do 2 times 8 minus negative 4 times 3, which would give us 16 minus negative 12, so in other words, plus 12, giving us 28. So again, just kind of rehashing, d sub x and d sub y are formed by using the column of constants as replacements for the coefficients of x and y. So we replace the x's, the x coefficients in d sub x, we replace the y coefficients in d sub y.